forgot to do this part, which was the first page of that sheet I gave you on division. So I'll get to it right away. And it has, well, I only gave you, it actually has more than one page, but I think I only gave you two. To be honest, well, you know what? Let's see how it progresses, and then I decide if I finish the whole thing once, and you guys can watch the rest later. So, first one, -6 3/4. Now, I think I spoke in class and I said you can think of division as multiplying the reciprocal of the second fraction. So -6/1, and I'm just going to write over here, that stays as it is. Division changed to multiplication, and the reciprocal of 3/4 is 4/3. Yes, you can multiply across, but we worked on this one a little bit. We want to simplify everything before we multiply. It makes our life easier. I can simplify the 6 and the 3. 3 divided by 3 is 1, 6 divided by 3 is 2. And I'm left with, well, negative times a positive is a negative, and 2 times 4 is 8. Okay? So basically that says if you had 6 units, right, of something, and you wanted to cut those units in 3/4 pieces, how many 3/4 pieces can you make? You can make negative, well, 8 pieces, but negative. Okay. So again, just reviewing divisions of the procedural part of division of fractions. So this is 13/4, right, divided by -13/5. And again, let's change that to a multiplication problem. 13/4 times -5/13. Okay, and then look how easy that is. These two can simplify, and you get -5/4. So yes, you can leave it like this, but if it's a multiple choice question and one of your answers is -1 and 1/4, you know that that would be the same as that. Okay. Likewise here. Okay, notice that, let me just recap a little bit here. Notice that the minus sign is not in the denominator, or it's not attached to the denominator, it's just there in the middle. It really doesn't matter. So if you have this, or this, sorry, or this, or even this, sorry again, or even that, right? They all have the same value. So if you put -4 divided by 7 in a calculator, or put 4 divided by -7, or minus and then 4 divided by 7, they would each lead you to the same answer. Okay, so it really doesn't matter where you put it. So in this case, let's just keep it where it is. And we're going to multiply that by the reciprocal of this, which is -14/20. Can I simplify things? Oh yeah, I can. The 7 and 14 can be simplified. 7 and 7 is 1. 14 divided by 7 is 2. 4 divided by 4 is 1, and 20 divided by 4 is 5. Look how much easier life is when I simplify before I multiply. So on the top it's just 2, the bottom is just 5, and it's negative times a negative is a positive, and our answer is 2/5. This one, now this, right, is the same thing as this. All right, so let's just do it, and hopefully I have some room over here. So it's 63.72 divided by -0.9. We're going to move the decimal 1 over, right? So that becomes a 9. And if I adjust that, guess what? I have to adjust this decimal as well. Move that 1 over. 63, so that becomes 637.2. And now it's just division. 9 goes into 6, no, it goes into 63 7 times. Subtract, becomes 0, bring that 7 down. 9 goes to 7, no it doesn't, so put a 0 on top. Don't forget the decimal. Now we're allowed to bring the 2, and 9 goes to 72 8 times. So our final answer is going to be negative, by the way, negative 70.8. Okay? This one, -56 divided by -7. Okay, so again, we know our answer is going to be negative, so let's 56 divided by -7. Let's see what kind of answer we get here. It's 8. Oh, sorry, I don't even know what I'm doing. It's just -8. This one is going to be a positive answer, So it's 0.125 divided by 0.5. Let's change the 0.5 to a 5, move the decimal over once, and we're going to make this into 1.25. Now we can divide. 5 does not go into 0. Bring the decimal up. 5 goes into 12 2 times. 10, subtract, you get 2. Bring the 5 down. 5 goes 25 5 times. Final answer, 0.25 positive. Okay. Now this one is a fraction over a fraction, so remember, sometimes it's easier if you see it like this. Okay. No big deal, right? So let's change this first before we change this to a multiplication problem. Change this improper fraction. I'm sorry, this mixed number to an improper fraction. So negative 9 over 14, that stays, nothing happens. Not changing it yet, so let's change that. So 20 times 1. If you like, you can always put an x here and a plus to remind you of what you're doing, right? So we're going to go this way, right, in that direction. 20 times 1 is 20, plus 5 is 25. Don't forget that negative sign, over 20. Okay, now that I changed this mixed number to an improper fraction, I can change it to a multiplication problem. 9 over 14 times 20 over 25, negative by the way. Can I simplify anything? The only thing I can simplify is the 20 and 14 divided by 2. 14 divided by 2 is 7. 20 divided by 2 is 10. So I'm going to get a positive number because they're both negative. 9 times 10 is 90. And 7 times 25 is 175. Oops. Oh, wow. Okay. So let me go back here. No, actually, I'm glad I made this, not error, but I didn't simplify to the fullest before. And that's why I got an answer that can be simplified. So I'm not too happy with that. Let me erase that. So going back to our problem, we simplified the 14 and 20, and guess what? I can simplify the 10 and the 25. 10 over 25, I can divide both by 5. 10 divided by 5 is 2, and 25 divided by 5 is 5. Now, there's nothing to simplify, and I will get an answer that's simplified fully. So 9 times 2 is 18. 7 times 5 is 35. So you notice my answer is already in its simplest form. And by the way, positive, because a negative times a negative is a positive. Where am I? Here. Okay, so this one is just, well, we know our quotient is going to be negative, right? So 40.6 divided by 0.5. Let's change that to 5. Multiply that by 10, becomes 5. If I multiply the inside by 10, I get 406, right? So that's basically what I'm doing. Think about it in this way. So it's 40.6 over 0.5, right? It's a decimal over decimal. I'm not too fond of that. So if I multiply the top by 10 and the bottom by 10, I'm going to get 406 on top, and 5 times 0.5 times 10 is 5, right? And this explains me moving the decimal to the right? Because that's, mathematically speaking, we're multiplying both by 10. So now that they're both whole numbers, makes our lives much easier. 5 goes into 48 times. Subtract 0, 6 comes down. 5 goes into 6 one time. I need 1 left over. Let's continue that by adding a 0. Bring that 0 down. 5 goes into 10 2 times. Don't forget the decimal. And done. So the final answer is negative 81.2. Likewise, this one is the same thing. It's very similar to the problem we just did, right? So we have to adjust. We're going to multiply this by 10. We're going to multiply this by 10. If I multiply the bottom by 10, I get 3. If I multiply the top by 10, I'm going to get 46.5 negative. Now I can divide. So 46.5 negative, right, divided by 3. Well, let me move that decimal already up here so I don't forget. 3 goes into 4 once. 3 left over. Subtract, bring the 6 down. 3 goes 16 5 times, which is 15. 1 left over again. Bring the 5 down, and then 3 goes to 15 evenly 5 times. All right, so it's a negative divided by a positive, so my answer is going to be negative. It's 15.5. Okay, so just a lot of I guess, refreshing what you learned last year. All right, because all of this should have been just walk memory lane. Let's continue. 10. So let's see. We have a water pail, and it has it's a bucket with a little hole in it, and it drained a total of 3.5 liters in 4 days. So every day, in 4 days, what's the average change in water volume each day? So you lost 3.5 liters of water in 4 days. That's my number sentence, and that's the problem I have to solve. So 3.5 divided by 4, 0.8, that's going to be 32. 3 down, let's continue. You can add a 0. 4 goes into 30, 7 times, 28. 2 left over, bring another 0 down. 4 goes into 25 times. So every single day, the change in water was 8.75 liters. Right? A loss. So if you write a loss of 0.875 liters, I would accept it. Or if you didn't write loss, you have to make sure that negative 0.85 liters per day, because then that would show me that you lost water, okay, instead of adding water. Running back for the Bulldogs football team carried the ball 9 times for a total loss. Okay, find the average change in field position on each run. All right, so he ran the ball 9 times, and in total, okay, so I hate questions like this because not everybody knows about football rules. So in football, right, if you guys see in the field, one team has a ball, and their objective is to carry that ball all the way, and now right here, end the zone. So they have to cross this line and bring that ball to that way, over to the end zone. Okay, so this running back, right? So he takes the ball and starts running that way, except that the other team can tackle him. And if they tackle him, depending on the position, they can tackle him and make him go backwards, or if he has the ball, and they tackle him and he goes backwards, he loses position. So I guess the defense on the other team was a little too good. So he carried the ball 9 times, and unfortunately, instead of going forward after 9 times, let me just say that he ended it somewhere over here, backwards. Okay, he kept losing yardage. So it's a loss. So again, your answer is going to be negative, but the change is going to be negative, right? So we're going to do 15 3/4 divided by 9. So you have choices over here. You can do that, or you can do that, whatever you want. Okay, so remember, right, we have numbers we can manipulate in any way we want. Okay, the way you feel comfortable to find your solution. So I don't have a preference. Let's see. Let's do it this way. 4 times 5 is 60. So that would be 63 over 4 divided by 9. If I'm doing it the fraction way, right? Divided by 9. Let me put the 9 over 1. I changed the mixed number into an improper fraction. Now I'm ready to change it to a multiplication problem. So I get 63 over 4 times 1 over 9. The 9 and 63 can be cancelled out with 1 and 7. Oh, I guess maybe that's not that bad. 7 times 1 is 7 on the top, and 4 times 1 is 4 at the bottom. And change that to an improper fraction, we get 1 and 3/4. So there was a loss, on average, loss of 1 3/4 yards per carry. So every time the poor running back got the ball, he actually went backwards 1 3/4 yards. Okay. Describe a real world situation that can remember the quotient 85 divided by 15. This is up to you. It's really up to you what you want. So let's divide 85 by 15 first and see what you get. Okay, so 7, no, 6, 5, 25, so it goes into 5, so that's 75. 10, 1, add a 0, add a decimal, which allows me to add a 0. 15 goes into 100 6 times. 6 times 15 is 90. So this is going to be 5.666 bar notation, right? So, or if you want to leave it as a fraction, it might be even better. So it's going to be 5 and 2/3. Okay, so 85 divided by 15 is 5 and 2/3. Can you describe a real life situation? So, uh, let's see, I had $85. No. Yeah, okay. So I was up up on a ski mountain. Okay, and I was up 85 feet. It's not really that much. Well, let's just say I was somewhere up on a slope. Okay, on the mountain, and I was 85 feet up. Okay, so every 15 seconds, no, every second, I want to know how much I dropped. So I'm skiing down, and from here to 0, 15 seconds elapsed. Okay, so I'm trying to find out how many feet, um, I travel per second. So every second, I travel 5 and 2/3 feet. So after 15 seconds, obviously, I was down here at 0. Okay. Hopefully, you'll get a better example than that. But hang on a second. My quotient was a positive quotient, so you might want to ignore what I just said because mine would be a negative, right? Have a negative connotation. Right, if I can think of something better, I'll come up. Okay. Hot air balloon descended 96 meters. So here we have a balloon that's up in the air. So hopefully I can draw this, a balloon, and here's land, and its distance right here is 99.6 meters. And it takes him 12 seconds, okay, so basically 12 seconds to come down. What was the balloon's average rate of descent per second? So how many meters did he travel per second on his way down? So again, it's just division of, so just basically 99.6 divided by 12. We can do that right away. So 12 times 8 is 96. Subtract, we got 3 leftovers, 36. And then 12 goes to 36 3 times. Our final answer would be the average rate of descent in meters would be 8.3 meters. Okay? So if you write that whole thing there, okay, your multiple choice might look something like this. Okay, 8.3 meters, negative 8.3 meters, so you definitely would want to choose this one. Beginning of 1996, a glacier or something. Glacier lost an average of 3.7 meters of thickness every year. Okay, find the total change in thickness by the end of 2012. Okay, so let's find out how many years is 2012 and 96. That would be 12 plus 4. What do you call? 16 years, right? So in 16 years, that glacier loses. What do you call? Lost. I'm trying to figure out how much he lost in 16 years. Right? So 16 years times the average meters of thickness that disappears. So every year, 3.7 meters of thickness of that glacier disappears, melts away. So 16 times 3.7, it's not a tough problem. So just again, I like to know that there's only one number after the decimal place in both factors that are being multiplied. So I know my answer will have one decimal place as well. 7 and 6 is 42, 11, 3 and 6 is 18, 9, 3 and 6 is 18, carry 1, 4. So if we add this up, we get 2, 5, 9, and because my answer has to have the same number of decimal places as the two factors I multiplied, I put it right here, right? Matches. So in 16 years, how many meters of thickness did that glacier lose? The glacier lost 59.2 meters of glacier. Okay. I'll continue. Okay, I'll continue because This way, when you come and do the back page, it's all in one video. So there's more. I didn't give you this middle page, okay? I might give it to you on Monday, but I'm gonna do the back page here. Okay, so that you have it all in one video. So again, you will have a calculator probably when you're doing this. But again, remember I told you a calculator is an extension of what you have, right, in your brain here, of your knowledge. So just because you have a calculator doesn't mean you'll get all the answers correct. So here Sarah borrows 13,707. Her niece charges no interest but requires equal monthly payments for 5 years. How much are Sasha's monthly payments? So 5 years, so that's nice. Multiply 12 times 5, there's 12 months in a year, times 5, that's 60 months. So basically the niece is saying you have 60 months to payment. You can pay the amount you borrowed in equal payments, so in equal payments for the next 60 months. So Sasha is going to pay $13,707 in 60 months. All right, so how much would she pay per month? So again, it's just a simple division problem. And this one, out of, well, I'll just do it. So that would be 2, 120, 37, 3, 6, 360, 0, 261, 60 again. How much do we have left over here? 47. Let me add a 0. Add a decimal. What is this number I just wrote? 26. Okay. That's a 6, by the way. So let's see if I can continue. 60 to 470 is 7 times, which is 420. 500 left, so bring another 0 down. 16 to 500 is 8, 480. We're going to go one more decimal place, okay? So 20, if you bring another 0 down, you'd be 60 going to 200 3 times. So it looks like it's going to be $261.78 rounded. Okay, so that would be the answer. Okay. So Don leaves 1/6 of his estates to each of his 6 children. If each children inherits 12,846, how much was the total estate? So you had something here. Let's divide this by 6, right? So, and then each of this is worth 12,846. This is worth 12,846. I know you can't see it, but this is 12,846, right? Because there were 6 of children. So each of these pieces of land is worth 12,846. So how much was the original value, right? So all you have to do is you can add this 6 times, or you can just multiply 12,846 times 6. 36 goes 3, 24, 27, 2, 55, 12, 17, 7. It looks like the original value of the state was 77,076. Please don't feel shy. If I make mistakes, let me know. Okay, so Martha leaves 4/5 of the value of her vineyard to charity. If the charity inherits of a value of what was the value of her vineyard? So think about it. 4/15 of value is 68,000, right? So we're gonna have 4/15 is equals 4/15 equals what do you call $68,542. I don't even know why I'm writing $452. Sorry, right? 4/15. So we can figure out what 1/15 was, right? So if I divide 68,000, let me just maybe draw it out. That might be easier. 2, 3, 1, 2, 3, 4, 5. So imagine this state here, and I'm going to shade 1, 2, 3, 4. It says that these 4 added up together equals 68,452. We want the value of the total land here, all parts combined, all 15th over 15th combined. So we can do, I guess a simple way is finding out how much right? So this is 115, this is 1 over 15, this is 1 over 15, this is 1 over 15, etc. We can find out what 1 over 15 is and then multiply by, what do you call it, 15. So 68,452 represents 4 of these pieces. So let's divide it by 4. So we get 1, 4, 28, 7, 28, 0, 4. 0, 5 goes 1 is, what do you call, 4 again, and 12 is 3. So we can, there's a nice even number value. So each of these 1/15th parts, so every 1/15th is equal to 17,113, which we can now multiply that by 15, right? Because now that we know what 1/15th is, we can multiply that by 15. And find 15, 6, 5, 35, and 8. When was the last time I multiplied these many numbers? 5, 9, 6, 6, 15, 2. So the total value of the whole state was 256,695. Okay. Todd claims 3/8 of his cell phone bill as tax-free write-off for his business expenses. He's trying. Okay, so again, you can think. So again, think of something that's divided into 8 parts. Okay, which is definitely not that. 1, 2, 3, 4. Sorry, right. 1, 2, 3, 4, 5, 6, 7, 8. So if I tell you that this 1/3, this 1/8, this 1/8, and this 1/8 equals to 726, can you figure out what the total is? This is just like the previous problem. Okay, we can figure out what 1/8 is because I know what 3/8 is. So 726 is worth 3/8. Well, let's divide that by 3, and then we can find out what each 1/8 part is, right? This is 1/8, that's 1/8, that's 1/8, that's 1/8, that's 1/8, etc. So 726, let's divide it by 3. Can we divide it by 3? 6 and 2 is 8, and 7 is 15. Okay, so it's divisible by 3. So we're going to get 2, 6. Once it's 0, so I'm going to have to. All right, so here's where I stopped. So before my battery died, let me just. So I was dividing 726 by 3. Right. So that would be 3, 2, 6, 12, 4, 12, and then 2. So we get that each share, or each 1/3, right? Each 1/3, sorry, each 1/8, my apologies. Each 1/8 equals $242. Okay, so what was the total phone bill? Well, the phone bill is, right, all these 1/8 parts added up together, and we know that each 1/8 is 242, and there's 8 of them, so 242 times 8, 1633, $1,936 was his total phone bill last year. Okay, seems like a lot. Okay, continuing. Mary claims again. So again, you see that these types of problems are a little bit repetitive. So Mary claims 5/8 of her house expenses as a tax write-off for the care of a disabled person. Her tax write-off was $5,840. So I think the idea of you drawing this or something in 8s definitely helps. So we know that 1, 2, 3, 4, 5 of these 5/8, 5 of those parts. So 5/8 have a value of $5,840, right, combined. So I can find out what 1/8 is by dividing 5,840, sorry, right, divided by 5, because I know 5/8 is 5,840 divided by 5. I'm going to get 1,508. 1 again, 5 subtracts 3, 4 down, 6, 30, 4 down, and 0. So 8 would be the last number. So each 8th here is worth 1,168. We want to know what the total value of all the 1/8 parts are, and there are 8 parts in the 8 parts here. So just simply multiply 1,168 times 8. 64 goes 6, 48, 54, 13, and it looks like a total value is 9,344. Okay, so let's scroll down. All right, so we have 17. He owns 120 shares of a stock which drops 14 and 3/8 per share in one day. How much money does he lose in that day? What? Hang on a second. What? Okay, so he owns something. Okay, and whatever he owns 120 of these. 120 shares of a stock. Okay, so he's owner. He owns a little piece of a company. Okay, so I have 120 shares, and each of them has a certain value. But I know that each of these 100 shares for that particular day lost $14 and $14.3 in value. Okay, so if you only had one share, that day, you would have only lost $14, 14 and 3/8. But because he had 120 shares, we have to multiply that 120 times 14 and 3/8 to find his total loss for that day. Okay, so you can multiply as a fraction, or you can multiply as 14 and 3/8 if you like. You can change 3/8 to a decimal, which would be 14.375. So you can do that, or you can multiply as a fraction, change this to a improper fraction, and multiply. It's really up to you. I personally, in this case, think this is the better way to multiply these two numbers. Okay, so times 120. I'm going to cheat here in the interest of time for you guys. 14.375, interest of time and my laziness. 5 times, and what do we multiply this by? 120. So in that particular day only, he lost 1,725 loss, right? So it's a negative. So he lost all that much money. Okay, but he didn't lose. Well, he did lose. The price of each of his share definitely took a dive, right? He lost in value. So imagine owning I don't know, what is it, 120 Pokemon cards, right? And they have a certain value right now, and then all of a sudden tomorrow nobody wants that Pokemon card anymore. So instead of a certain value that it was today, tomorrow it's $14.375 less for each of those cards. So in total, because he had 120 cards, you have to multiply that to find his total loss for that particular day. Okay, so again, this next question looks very similar. He owns 480 shares of a stock, okay, and this particular stock goes up. So the value of whatever you're holding goes up $5.03 or 5.75. So because you have 480 shares, you have to multiply that by 5.75. All right, so definitely this is a good day for you, and in total, you can multiply those two numbers, and you get 480 times 5.75. It's going to be 2,760. So that's how much you would have gained. So let's say you held 480 Pokemon cards, and they all have the same value for whatever reason. And then tomorrow, each of those cards go up in price by $5.75, and you decide to sell it. Okay, you would have $2,760 extra tomorrow than today. Okay, so the next set of questions are a little bit different. What number must be multiplied by 2/3 so that the product is 56.5? So key here is setting this up as an equation, right? So think of it. So what number, a number that I don't know, which I'm going to call x, okay, multiply times 15 and 2/3 is going to give us 56.5. That's my little setup, right? So the one thing I'm going to change here, I'm going to change these to improper fractions. Okay, so x times a number, so x, notice that, let me just write 3 times 15 is 45, so this is 47 over 3, right? So it's x times this number, a number that I don't know, times 47 over 3 is supposed to give me 56.5, or in this case, 113 over 2, right? Because I'm changing it to an improper fraction. So now, how do we isolate this? Remember when we were doing one-step equations last year? So we want to divide this by 47 over 3, right? I'm going to divide this by 47 over 3. So what ends up happening is that these two simplifies to 1, right? Because 47 over 3 divided by 47 over 3 is just 1. And what's 1 times x is just simply x. So on the other side, we actually have to do the problem. So remember what that is? It's 113 over 2. So let me write it on top here. 113 over 2 divided by 47 over 3. We change that to a multiplication problem. We do it by the reciprocal, which is 3 over 47. And there's nothing to simplify here. So the final answer is going to be 94 at the bottom, I believe. And then on the top, it's going to be 339. So the answer is that. So 339 times 15 and 2/3 equals 56.5. 339 over 94 times 15 and 2/3 equals 56.5. Okay, so the key here is not the procedure, because that you already know how to do. The key is setting it up in this manner. Okay. Second question, again, just so that you practice, get a little practice. So x times 12 and 2/3. Allow me better. I'm going to write this the proper way. So 12 and 2/3 times x, right? Times a number. I just switched the order. 12 and 2/3 times a number has to equal 56. So let's change that to an improper fraction. 3 times 12 is 36 plus 2. So 38 over 3 times a number that I don't know equals 56. We're going to divide both sides by 28 over 3. Divide this side by 38 over 3. These two simplify to 1. And x is going to be 56. Let's change that to division problem, multiplication problem. 3 over 38. And can we simplify here? Divide by 2, I guess, is the only thing. So that's 19, and this is 28. So we end up getting 84. Sorry, 84 over 19 is our number. So if I multiply 12 and 2/3 times 84 over 19, I get 56. So just to 84 over 19, just to prove it, 12 over 2/3 times 84 over 19 should give me 56. Let's substitute and confirm if our answer is correct. Let's change 12 and 2/3. Again, that's 38 over 3, right? 3 times 12 is 36, plus 2 is 38 over 3 times 84 over 19. Does that really give me 56? Can I simplify? Yes, there's a lot I can simplify. 19 divided by 19 is 1. 38 divided by 38 divided by 19 is 2. 3 and 84, I can simplify. 3 goes into 84. 2, 6, 28 times. Good. 3 divided by 3 is 1, and 84 divided by 3 is 28. So what do I have left over? 2 times 28. And is 2 times 28 equal 56? Yes, it is. So we are good. Okay. All right, so what must be divided by 28 so that the quotient is 35? So again, you can use any variable, a, b, c, x, all right, divided by 28 and 3/5 is 35. Okay, so this I actually would much rather. Oh, let me see how I can do this for you guys. Give me a second. So, because I much rather write it like this. Okay, so I'm gonna, instead of writing it this, well, it's the same thing. So first of all, let me show you that. Writing it like this, 28 divided, so a number divided by 28 and 3/5 equals 35, and this is exactly what this also says. 28 divided by a number divided by 28 and 3/5 equals 35. So to solve though, I'm going to use this one, this version. It's much easier. So remember, our goal here is to isolate x, right? To leave x by itself. So in order to do that, we have to get rid of this 28 and 3/5. And what we do here is multiply both sides by 28 and 3/5. Multiply this side by 28 and 3/5. Right? So remember, can I simplify this one with this one? I can definitely do that, right? So now I am left over with just x, which is what I wanted to begin with, and then all I have to do is multiply 35 times 28 and 3/5. Let's do that. So 5 times 28 is, I have no idea, 40 goes for 140, so it's going to be 143 over 5, and so put the x, and then this simplifies with this, and final number x equals 7 times 143, which equals 1001. Okay. So this one, again, I'm going to write it. So let me use y. Y divided by 15 and 3/4, a number divided by 15 and 3/4 equals 60. So let's isolate our variable y. And to isolate that, I need to get rid of this bottom. So let's multiply both sides by 15 and 3/4. Right? This allows me to simplify that. That becomes 1. And then 1 times y is just y. On the right side is just multiplying. 4 times 15 is 60, so 63 over 4. Can we simplify? Yes, this becomes 1, this becomes 15, and y equals 15 times 63, which, according to the calculator, equals 945. That's the value of y. Now, let me take a step back, just in case. So imagine if you had a over 6, right, equals 18. A number divided by 6 equals 18. So when you learned it this last year, in order for that equation to look like this, where the 6 is gone, what can I do? Well, if I multiply this by 6, I have to multiply the other by 6, right? So on this side, it's easy. 18 times 6 is 48, 108. On this side, let me put the 6 over 1 for a second, right? The whole number over 1. So what can I do? I can actually simplify this 6 with this 6. It becomes 1, right? And if you see that 1 times a is just a, and it becomes a over 1, actually. And a over 1 is just a. So that's why you multiply both sides by whatever the denominator is, so to simplify it. So going back, let me just do the previous problem. This is no different. So when I did y over 15 and 3/4, right? Remember, it's a fraction. This is a denominator right here, equals to 60. I want to get rid of the denominator of 15 and 3/4 and just leave the y. But in order to do that, I'm going to multiply, right? So pretend I'm going to put 15 over 3/4 over here over 1. And this simplifies to 1, right? Because that divided by that is just 1. And that's how I get y all by itself. And then 60 on this side, we already did that. We multiplied that by 3/4 and get whatever answer I got. Okay. Next one, if 1/2 of 3/4 of a number is 60, what is that number? So again, how do we write that as an equation? So a half. Hang on a second. So half, right? Remember when we were doing expressions last year, translating verbal expressions into equations. So half of 3/4, 3/4 of a number, and of right translates to multiplication, right? So half of means multiply. 3/4 of, again, a number that I don't know, let's call it x, equals 60. So that's what your little equation looks like. We can simplify this. 1/3, 1 times 3 is 3. 2 times 4 is 8. So you end up getting 3/8 of a number equals 60. We can easily find what the number is. Right, in this case, again, I want to isolate my variable x, and I need to get rid of this 3/8. And in order to get rid of the 3/8, I simply multiply it by 8 over 3. And if I multiply this side by 8 over 3, I have to multiply this side by 8 over 3. So this allows me to simplify. Look, ta-da! All that is gone and leaves me with x, which is what I wanted. And on this side, I can simplify 3 and 60. 3 divided by 3 is 1. 6 divided by 3 is 20. And 20 times 8 is 160. So there is my answer. Bottom, same thing. 2/3 of a 4/5 of a number, let's call that number A, equals 120. What's the value of A? All right, not that difficult. 2 times 4 is 8. 3 times 4 is 15. So we got 8 over 15. A equals 120. Let's get rid of the 8 over 15th by multiplying by the reciprocal. Multiply the other side by the same, 15 over 8. Whatever I do to one side, I must do the other side. That goes out, becomes 1. These two simplify to 1, and all I have left is 8. Can I simplify 120 and 8? Yes, I can. 8 divided by 8 is 1. 120 divided by 8 is 115. Okay, and 15 times 15 is 225. The value of that letter here. So 2/3 of 2/3 of 4/5 of 225 equals 120. Okay, that's it. It's just a lot of work, but nothing too complicated. Okay.